Hello, this is a tutorial on the expressions and equations review assignment. We are going to, in this first one, write an algebraic expression to represent the situation. The Valley Middle School students were divided into 12 groups. Use S for students. Well, here's the students. We're dividing them into 12 groups. Now you might write it this way too. Students divided by 12. I prefer this, and I think most teachers were going to prefer the fraction bar. Okay, the next question, prove that m equals 23 in the equation below by using the inverse operation to balance this equation, isolate the variable. Well, what we have to do here to do that is we're going to add 13 to each side. Okay, that's going to balance the equation because we're doing the same thing. We're using the opposite operation. That's what inverse means, opposite operation, and balance, we're doing it at both sides, and then we've got m equals 23. And if you want to put some little railroad tracks down there, you could do that as well. I'm thinking of a number that when doubled, then decreased by 3 is 27. What number am I? So let's think of this. Here's a number, and we'll double it, and then we're going to decrease it by 3, and that is 27. See how I did that? Took a number, m, I doubled it, I subtracted 3, and it is 27. So when I add 3 here, we'll isolate this to solve this. You could probably do it in your head. So now we have 2m equals 30. And if I divide it by 2 on both sides, I get m equals 15. 15 is my number there. See if I can zoom this just a touch. All right. Write an equation that represents this situation. Abby went to Target with some money. She spent $14.65 on groceries. She has $9.35 left. So let's use M again. She had some money. She spent this much. And this is how much she has left. Another way we could do that is we could think about $9.35. Plus the $14.65 equals the money that she has. And I know a lot of kids are going to think that's okay, but the problem is that this variable here, when you write it that way, is off by itself. We want the variable with an operation. So please, this is the answer we want right here. Okay? Even though you might be thinking about this one in terms of solving it. When we write it, we want to have that m minus 1465. Okay? Prove that f equals 16 in the equation below by using the inverse operation. Okay. Well, so we will subtract 29 from this side. We'll subtract 29 from this side. These cross off. We've got f isolated. And then 45 minus 29. 15 minus 9 is 6. Now we've got 3 here. Minus 2 is 16. So there I've proven that f is equal to 16. I can pop it into 16 plus 29 does equal 45. That's my check. Alright, solve the following equation by using the inverse operation to balance the equation and isolate the variable. Well, this here is multiplication, so we solve multiplication and isolate by the opposite operation, which is division. So I'll divide both sides by 5. These cross off. We've got 7 equals r. We can double check it. 35 equals 5 times. We'll just put 7 in parentheses. Yeah, 5 times 7. Got a little matching section here. Match the letter in front of each word in the column on the left with the correct letter in the word on the right. So product means multiplication. Quotient means division. Subtraction, that's difference. And sum is addition. So BCAD. Write an algebraic expression to represent this situation. 6 more than the number is equal to 15. Well, here's the number. And then 6 more would be add 6 and is equal to 15. There's your algebraic equation right there. All right, and we've got another matching one here. Match the words in the left with the words in the right. So decreased by, that's going to be subtraction. So the A there. More than, that's going to be addition. Twice, that's multiplication. And put into groups, that is division. So that's DACB. Okay, let's keep rolling here. Write an algebraic equation to represent this situation. We have 8 less than 5 times the number is 42. So we'll do this one first, 5 times the number. So here's 5n. And 8 less would be minus 8. And that means equals 42. So it looks like n is going to be 10 in this situation. 5 times 10 would be 50, minus 8 would be 42. But we don't have to solve it, we just have to write the algebraic equation. Okay, Shanique found the solution to the equation below to be j equals 10. Is she correct? Well, let's just pop it in and see. 30 equals 15 plus 10. Is she correct? No. Let's just figure out what it would be. Let's subtract 15 from both sides. And 15 is equal to j. No. J is equal to 15, not 10. Okay. Write and solve an equation. The equation is modeled. We got something, and we got 20 on one side. We got 40 on the other. So we could think about this as being like something plus 20 equals 40. So, we could solve this. Subtract 20 from both sides. We can get m is equal to 20. That's one way to interpret that. Some people might think, well, I want to do this like this way. 2 times that 20 would be equal to 40, and that would work. So you could say, your answer might be, 2m equals, sorry, it's not 20, it's 20. It would be 20m equals 40, and that would be fine too. And there's probably some other ones. It depends upon how you interpret that. That's why I kind of like this problem. I think most people are going to go with the addition route here, but they don't give us an operation, so it kind of gives us a little bit of flexibility there to think outside the box. Okay, you eat 3 cookies and your friend eats 6 cookies. There are 18 cookies left in the package. Write and solve an equation to find out the number of cookies in full package. So there are 18 cookies left. You eat 3 cookies and your friend eats 6 cookies. There's a bunch of, we can think about this as saying, here's a bunch of cookies, and then you eat 3 and your friend eats 6, and there are 18 left, which we can really write as some cookies minus 9 equals 18. And now we have a one-step equation here where we're just going to add 9 to this side, add 9 to this side. These guys cross off, and you've got the cookies is equal to 27. So there we wrote and solve an equation on that. You don't have to do this step. You can go right to this one. You can just add the 3 that you ate and the 6 that your friend ate together too. I'm thinking of a number that I doubled and from which I subtracted 5. So I'm going to say 2 times some number, and I subtracted 5, and I got an answer of 9. Can you figure out what the secret number is? Well, let's double check this. I doubled a number, I subtracted 5, I got 9. So let's add 5 to both sides. We've got 2 times a number is equal to 14. I'm going to write that up here. 2n is 14. Now I can divide by 2. And I've got that number is equal to 7. Let's double check it. I took a number, I doubled it, that's 14, and then I subtracted 5. 14 minus 5 is 9. Yeah, there we go. Number is 7. All right, just 2 left. Solve the following equation by using the inverse operation to balance the equation and isolate the variable. This is a two-stepper, so first we have to add 8 to both sides. Now we've got 4m is equal to 40. So now I'm going to divide by 4 on this side. I'm going to divide by 4 on this side. These guys will cross off. Just move this over here. And we're going to have m equals 10 left. Sorry, I have to put my railroad tracks in there. M is equal to 10. Let's just try it. 4 times 10 would be 40 minus 8 is 32. Yep, there's my check. All right, write an algebraic equation to represent this situation. 23 less than a number. Well, here's a number, and 23 less is just minus 23. Okay, thanks for listening. I hope this helps.